All right, so today's lesson is going to be in terms of heating and cooling curves. So if we were to draw a graph, and we're going to look at temperature in degrees Celsius on the y-axis, and we can look at our x-axis in terms of heat or time, okay, depending on the graph and who graphs it. We might look at it as heat or as time. What we find as I heat a substance and I collect data, I find a graph to look something like this, where I have my solid, my liquid, and my gas. So if this was water, we know that water goes from a solid to a liquid at 0 degrees Celsius, and it goes from a liquid to a gas at 100 degrees Celsius. As my solid increases here, as I'm adding heat, my temperature is going up. So my solid temperature goes up. At some point, my solid starts to melt, and I go from my solid to my liquid. Now, we've already seen that this is going to be an increase in potential energy as we go from a solid to a liquid. All right, and when I go from my liquid to my gas, we see this is our vaporization, and we've looked at this heating curve already, but let's talk about it now in terms of calculations. I could calculate where my solid, my liquid, and my gas are all going to use the equation Q equals mc sub P delta T. All right, and my specific heat is going to be provided for you, and that is the C sub P. So C sub P is specific heat. These values are provided for you on your reference tables. All right, on page 1, we have the specific heat of a bunch of different metals, but we also have the specific heat of water as well, where the specific heat for ice is 2.05. The specific heat for steam is 2.02, and the specific heat for water is 4.18. And you'll notice our units are all the same. Joules divided by gram degree Celsius. So all specific heat has those units, joules divided by gram degrees Celsius. My phase change is Q equals M heat of fusion, where M is the mass, and the heat of fusion of water is provided for you on your reference tables, 334 joules per gram. Notice degrees Celsius is missing because temperature is not changing at that phase change. During my vaporization, Q is going to equal M heat of vaporization, VAP for vaporization, and my heat of vaporization of water is 2260 joules per gram. Again, degrees Celsius is missing because temperature remains constant. We are measuring heat in terms of the joule, which we will use a J for. And we said that C sub P is the specific heat. And what is specific heat? Specific heat is defined as the amount of energy needed to raise the temperature of 1 gram of substance by 1 degree Celsius. Okay, so let's do some practice problems with this information. Let's say I have 20 grams of steam and my initial temperature is 101 degrees Celsius and my final temperature is 150 degrees Celsius. So if I have water here, if I'm at 101 and then I go to 150, I'm in just this section. So Q is going to equal MC sub P delta T. Where M is my mass and Q is our heat, okay, in joules. So M is my mass, so that's 20 grams. Now, the specific heat for steam, according to my reference tables, is 2.02 grams per joule. I'm sorry, joules per gram degree Celsius. And my change in temperature. This is delta T is change in temperature. It will always be final minus initial. So my final temperature is 150. And my initial temperature is 101 degrees Celsius. So when I plug this into my calculator, I'm going to get a value of let me plug this in real quick. $197.9.6 joules. All right. And now we would do sig figs here. I haven't really done correct sig figs here. Let's just assume everything was to 3 sig figs because your problems that I give you will have good sig fig values. All right, so that would be, if we wanted to put this in 3 sig figs, that'd be 1980 joules. Remember, when in doubt, scientific it out. If you don't know, then you can, when in doubt, scientific that out. Give me 3 values. So if we were to scientific out this value, it would be 1.98. Give me 3 values times 10 to the second joules. And this value is the same as that. All right. Let's do us another problem. I have 20 grams of liquid water where my temperature is 15 and my final is -3. So I am a liquid. I am then freezing to become a solid with a temperature of a -3. So that is a 3-step problem. Q equals MC sub P delta T. Q equals M heat of fusion, and then my Q equals MC sub P delta T again for the solid. So a 3-step equation. So let's start with our Q1, that is our temperature of our liquid. So Q equals MC sub P delta T. My mass is 20 grams. My specific heat of water is going to be 4.18. And my temperature. Here's where students get messed up. If this is water, I started at 15 degrees, but water freezes at 0 degrees. So my final temperature for the first step is 0. So I'm going to do 15 or 0 minus 15 degrees Celsius. All right, so when I plug that into my calculator, that is going to give me a negative Q value of 1254 joules. Now my second step is my freezing. When I freeze a substance, what happens? Heat is being lost, all right? Because we're going from a liquid to a solid. Heat is being lost. So I'm going to put in my mass of 20. And my heat of fusion, according to my reference tables, is 334 joules per gram. However, heat is being lost. So to show that heat is being lost, we are going to make a negative because the negative does not tell me the magnitude. The negative tells me that heat was lost. So when I plug that into my calculator, I am going to get a value of negative 6680 joules. Now, I'm at this point. My temperature then decreases to -3. So I am going to come down here. Q equals MC sub P delta T. So I have one more Q problem. Q is the MC sub P delta T, where my mass is still 20 grams. Now my specific heat of solid ice is 2.05 joules per gram degree Celsius. Now my temperature change. I started at 0. I decreased to -3. So my final temperature is -3 minus my initial temperature is 0. Be careful, this really tricks students up sometimes. Students really get messed up with their final and their negative. Pay attention to your heating curve. So when I plug that in, I get a negative 123 joules. So how much total heat? Q total is going to be my Q1 plus my Q2 plus my Q3. So that was my 3, my 2, and my 1. So I'm going to simply say negative 1254 joules plus negative 6680 joules plus negative 123 joules. And I'm going to just add all of those into my calculator. So I'm going to do 1254 plus 6680 and the 123. They are all as negative values. So that's going to give me 8057 joules. And again, when I add them all together, they were all negative. So that is a negative value. So there is my overall heat released when 20 grams of steam, 20 grams of liquid goes to a temperature of -3 from a temperature of 15 degrees Celsius.